7 visitors in one sky. A headline that sounds unbelievable, yet it's real. By the end of 2025, 7 major comets will sweep into the inner solar system within just 6 months. Nothing in the digital survey era has come close to this. Among them is 3I, Atlas, only the third confirmed comet to arrive from another star system, glowing with a vast green halo and carrying chemistry unlike anything we've seen before. Statisticians estimate the odds of such a lineup at less than 0.5% per decade. That's why astronomers are asking, is this merely coincidence or a signal that the sky is playing by rules we don't yet understand? How we catch them? Night after night, an automated grid of sky-watching telescopes, pan-stars in Hawaii, Atlas, and others perched in Chile and South Africa, scan nearly the whole sky. Their cameras are sensitive enough to register objects fainter than Pluto. The process is mechanical but relentless. Each new set of images is checked against a digital memory of the sky. If a pixel shifts, if something is moving against the fixed background of stars, it sets off an alert. Within hours, telescopes worldwide turn to confirm the find. In the old days, spotting a comet required patience and luck. Now, hundreds are logged each year. Yet even with this technology, 7 significant comets crowding into 1/2 year is an outlier of outliers. The basics: orbits, brightness, and tails. Perihelion is the point when a comet is closest to the Sun, the moment when heat drives outbursts of gas and dust. Astronomical unit, O, equals the Earth-Sun distance. If a comet comes within 0.25 astronomical units, it's just a quarter of that gap from the Sun. Magnitude scale. Lower numbers mean brighter. Magnitude 6 is the faintest most people can see unaided. Magnitude 2 or 3 rivals bright stars. Every comet grows at least one tail. Dust tails glow pale and curved, shaped by sunlight. Ion tails are thin, blue, and straight, pushed by the solar wind. Sometimes, a solar storm slices an ion tail completely off, a sudden and spectacular, tail disconnection, event. With 7 comets inbound, 2025 may deliver several such moments, possibly captured live by spacecraft. The cast of 2025, not all comets will dazzle. See, 2022 Pan-STARRS, perihelion, July 31st, approximately 3.8 astronomical units, and 240p, NEAT, perihelion, December 19th, approximately 2.1 astronomical units, will remain faint smudges, targets for dedicated amateurs rather than the public eye. But others may shine. Swan, C, 2025 R2, comes within 0.25 astronomical units of Earth on October 21st, just 37 million kilometers. Forecasts put its brightness near magnitude 2 or 3, visible to the naked eye at dawn. Atlas K1 dives deep inside Mercury's orbit by October 8, likely erupting in dramatic jets. Comet Lemon, C, 2025 A6, swings by in November, possibly glowing at magnitude 4 in evening skies, a classic binocular target. Meanwhile, 414p, stereo will stay hidden in the Sun's glare, but spacecraft like SOHO and Stereo are poised to catch it. And then, there's the wild card, 3I, Atlas, the interstellar newcomer. The outlier, 3I, Atlas. Observations from Hubble and JWST reveal its coma, the glowing envelope of gas, spans nearly 700,000 kilometers across, dwarfing even Jupiter. Jets erupt constantly, sometimes changing within hours, turning the coma into a shifting green cloud. What shocks researchers most is its chemistry. Instead of water vapor driving activity, carbon dioxide dominates by an 8-to-1 ratio. This suggests it may have formed in the frozen outer reaches of another star system, where carbon dioxide could accumulate in bulk. Models predict that by mid-2026, Earth may pass through the dust stream of 3I, Atlas, possibly triggering a meteor shower made of true interstellar grains. Particles formed around another star, burning up in our sky. Is it dangerous? Whenever multiple comets appear in quick succession, public curiosity rises, and with it, a wave of unease. Whispers of doomsday comets, or cosmic collisions, spread rapidly online. But the truth is far calmer. None of the 7 approaching comets pose any threat to Earth. Their orbits have been carefully calculated and rechecked by agencies such as NASA, the European Space Agency, ESA, and observatories around the globe. The closest pass, Comet Swan, will still be about 90 times farther away than the Moon. To put that into perspective, that's over 34 million kilometers of safe distance. Even the fastest comet in the group, Comet Lemon, will skim the inner solar system without entering the slightest danger zone for our planet. The scientific verdict is unanimous. These visitors are here to be watched, not feared. How to watch for skywatchers. The season begins quietly but builds toward a celestial crescendo. October 21st, dawn, Comet Swan will make its closest pass, rising faintly in the eastern sky just before sunrise. Naked eye visibility will be limited, but those who rise early with binoculars may spot its faint greenish glow, a result of carbon molecules fluorescing in sunlight. November 6 to 12, dusk, Comet Lemon enters the stage. It will hover low in the western twilight, potentially bright enough to be glimpsed without equipment if skies are especially clear. With binoculars or a small telescope, observers might trace its shimmering tail as solar radiation pushes dust and gas away from the icy core. The key to comet watching is patience. Comets are notoriously unpredictable. A small outburst of trapped gases can suddenly brighten them by several magnitudes overnight, while others fade into invisibility just as quickly. Each night offers the possibility of surprise, nature's way of keeping even seasoned astronomers guessing. The bigger picture comets are more than just pretty sights in the sky, they're time capsules. Each nucleus is a frozen relic from the birth of the solar system, preserving 4.6 billion-year-old chemistry within its icy heart. When sunlight heats their surfaces, they release dust and vapor, creating the glowing comas and tails that enchant us from afar. But for scientists, every wisp of gas is a clue, a message from the deep past, offering insight into the materials that once seeded Earth with water and organics. What makes late 2025 so extraordinary is not just the appearance of 1 or 2 bright comets, but the clustering of 7 within a single season. No modern record matches it. According to orbital dynamics, such close arrivals should be vanishingly rare. Yet here they are, lined up almost like a cosmic parade. There are 2 possible explanations. One is that this is simply a remarkable statistical fluke, the sort of improbable event that occasionally happens in a universe governed by chance. The other possibility is far more intriguing, that unseen processes in the far reaches of the Oort cloud, the icy halo that surrounds our solar system, have been nudging comets inward, perhaps triggered by gravitational interactions or subtle forces we do not yet fully understand. A season for discovery whatever the cause, the months ahead represent a unique opportunity. Astronomers will use the comets as natural laboratories, measuring how solar wind and radiation sculpt their tails, studying how organic compounds evolve under sunlight, and even searching for grains of interstellar dust hidden within their debris. For the public, it is a reminder of the universe's beauty and unpredictability. To stand beneath a night sky illuminated by not one, but several comets, is to glimpse both the fragility and grandeur of our place in the cosmos. 7 visitors, 1 sky, and a season unlike any in living memory. The heavens have opened their book, and for a brief moment in time, we are invited to read its new